My microphone. There we are. Okay. So I think there are a few of you out there. I said there were about 7 of you waiting. Let's see if you've checked in. Ah, yes. Isabella, Jiwoo, Joel, Noah. A slightly different mix. Okay. Let's see how we're doing this morning. Whoops, that's not what I want. I want to get back to chat. This is frustrating. There we go. Morning, Patrick. All right. So how'd you manage the storm last night? My audio working okay? Morning, Noah. Well, we got sound. I just want to check. I never quite know. I can't check it from my end. No, oh, someone's typing. Uh, oh, okay. All right. Yeah, stormy night last night. Hey, pretty wild. This is what it looks like this morning. This is just looking out off the deck to see what it's like down on the water. And as you can see, in one direction, it's pretty stormy. And if I look in the other direction, similarly, it's pretty wild in terms of the waves out there. Not as crazy as after a hurricane. And it probably will pick up a little bit. This is all just storm surge. So the water isn't actually that rough. They're big rollers coming in. But usually it's a few hours after the winds have died down that we see some of the big waves. So let's get going here now. Oh, Dora on the weekend wanted to go and see fishing boats. So these are the fishing boats, a couple of lobster boats, and the ones on the other side of the wharf are scallop draggers, I think. Um, and this is at Riverport. And this is the lobster boats over at Felton South. And it's a nice little harbor at Felton South. The Riverport's more industrial. It's where fish plant used to be operating. I don't know if it still does. So we're into the last stuff for the term, and that finishing up evaluation today. On Wednesday, I'm going to be looking at deployment and some issues there and some advice to you on using charts and graphs. But then next Monday is Easter Monday, and then we've got one class after you've done your last assignment, last quiz, everything, uh, a week from Wednesday. Unless there's some big desire for you to have some big party class at the end, I'm going to cancel the one for Wednesday of next week. Um, I've got no other plans. I can easily do it, but I just don't think there's going to be much of a turnout, and you don't need it for anything else in the course. You're going to be finished on Saturday. This class will be completely finished, and I should be able to work out grades at the beginning of the week. So, yeah, the end's in sight. I do want to mention before I get into material, we've now got 106 responses as of this morning to the survey about the course. Skimming through comments, useful. In other classes, I guess they've been using polling and quite successfully. Students want to see more of it. So I'm getting some feedback and having it across all the sections, and each of us have taught a little bit differently, getting some good feedback on what to do, what not to do. But I thought you might be interested in this. This surprised me. I'm going to have to share it with others. Don't know how well you can see this. Let me see if I can blow it up a little bit more. So of the 106, one of the first questions I asked is, how do you take the course? Synchronously, mix, synchronous, asynchronous, um, that mostly asynchronous, not watching videos, or mostly asynchronous, watching videos. And then if you were to take the course or a course similar to it, like stats, for example, in the fall, how would you like to take it? And these aren't in proper sequence, but the first was face to face, Second was synchronously online, so like the way we're doing it today. Asynchronously, so just watch the videos afterwards if you wanted to watch them, or a combination of all of those. And it's interesting to see that um, now it's a somewhat biased sample. About half said that they attended most lectures, and I don't think that's the case. I think it's people like yourself have been more likely to respond to the survey. Um, and the ones that said a mix of synchronous and asynchronous, that's another large chunk. So those people that have been tuning into lectures make up 2/3 of the respondents. But look at what they want to take it as. There's a whole bunch want to take it asynchronously if they were to take it again, sort of thing, or synchronously online. Less than half, say about half, want to take it as a combination. So I don't think the university is aware of this. I'll be sharing it with the administration. I've been after them that you're going to want a combination that um, that even if there was no risk in the future with face to face, that a lot of the feedback is that you appreciate having recorded classes. You'd like that to be something done forever into the future, regardless of how we deliver the course. If you miss a class or whatever reason, that you can pick up what happened in the class through a recording. And I think that's here to stay. We're going to have to change the technology in our classrooms to be able to support that. But uh, and even taking courses just online or asynchronously, I think many of you would have been hesitant to do that. We didn't have huge take up with online courses in the past. When students have a choice between face-to-face and online, generally they would opt for face-to-face, only doing it online when they had uh, personal restrictions, that they weren't in Halifax, they were finishing up courses and they had moved back to New Brunswick or wherever they're from. Uh, that So online was uh, something if you're in special circumstances or because there were no seats face to face. But you've had a different experience this year, and that's opened different views on things. The business model has changed. This is, and it's just like everything else that you've seen change, the way uh, companies do business, the way you shop online, the way we do all kinds of things. Um, Marketplace is completely different, which is I find fascinating. It's a very I'm always interested in disruptive things, either in disrupting processes or to improve service, that type of thing. But also in this is an interesting experiment. But we've got stuff to finish up today, and let me try to zip through that as best I can. That we did evaluation last time. I had all of these different performance measures, and there's an awful lot written about them. That often when they're evaluating models, that's the way it's done. It's generic in a sense because uh, you're not measuring consequences, you're just measuring error rates. It's sort of like R squared in a sense, but it's complicated because there were so many different ways to measure it. So suppose we're interested in measuring just average performance, but let's take into account consequences. And that it's important to understand this concept that we're going to call expected value. So suppose you just have a marketing campaign that each promo that you send out digitally or however is going to cost you 10 cents, $0.1. And if they buy it, you get a profit of $15. If they don't buy it, you've wasted your 10 cents. That, and let's suppose only 1 in 100 buy the product. Okay, it's actually a pretty high take up rate. Is the promotion a good idea? Well, what you could do is look at what you would expect if there were 100 people, 100,000 people you sent the promotion to. Out of the 100,000, you would expect 1 in 100, so that would be 1,000 to actually buy. Times $15, that's $15,000. But you would expect 99,000 not to buy. Okay, and for those, you're going to lose 10 cents on each one. And that adds up to a lot of money, almost $10,000, 9,900. But the net effect of the two is you have a net profit of $5,100. If you're wondering, well, I didn't charge the 10 cents to the people that bought. I said the profit was 15, so I presume I'd be incorporating the cost of the promotion with those people that bought it. But we make a net profit of $5,000. We make on average 5 cents, $0.051 for each customer. So we make little tiny amounts on each customer that we send this to, but multiplied by a large number of customers, you make money. And if you're doing this over and over and over again, many, many, many times, you make a lot of money. Sounds good. Could we do it better? Well, we'll get to that one. First off, summarizing what we've done, and uh, you could come up with a formula. It's called expected value. And expected value is the sum of the outcome times the probability. So each of the different outcomes, multiply them by their appropriate probabilities. Outcome of $15 times 0.01, and the outcome of minus $0.1 times 0.99. So I've got all of the probabilities, 0.01 plus 0.99, both possible outcomes, and the profits or costs associated with each one. And this comes out with the overall average across all customers. And this is sort of what we did, because remember, this is like 1,000 divided by 100,000, 99,000 divided by 100,000. So I calculated all the profits and then divided by 100,000. That's what I did before. It's the same calculation as I did previously. This measure is far and away the most popular, most widely used measure of performance of decisions under risk. In finance, where you're looking at investments with probabilities with different outcomes, they use expected value to measure, on average, how much do they make with this investment versus another investment. They make trade-offs, but when looking at terms of the long-term average, this is what they'd use. If I'm looking at, if you did Quant 1 and you're looking at these, you probably did finance examples of saving for retirement, common example used. You're looking on average how much you're going to earn as a return in the future. You don't earn 6% per year every year. Some years the markets are really great and you're making 12%. Other years the markets are bad and you're losing 8%. It bounces all over the place, but on average it's 6%. And in the sense when we work out those calculations, it's on average, what would you expect to be able to earn? That This one actually had nothing to do with a model, this past one, because we just sent that promotion to everybody. So suppose you analyze data on your customers, and so that you identify ones likely to respond to a promotion versus those not likely. So you're going to target your promotion, and this is where the data mining comes in. That the ads, the promotions, the discounts are targeted to specific people, the ones that most likely to be influenced by that promotion. And so if we put it out there, we send out the promo, and let's suppose our model suggests sending it out to 2,000 people, not to all 100,000. So the other 98,000 aren't going to receive it. But if they had, we would have found that about 900 of those sent the promotion would have bought it, and maybe about 100 of those that you didn't send it to, if you had sent it to them, they would have bought it. Okay. Um, and then among those that you sent it to, we would expect about 1,100 not to turn you down. But then another large chunk, 98,000, that you didn't send it to, they probably weren't going to buy it anyway. So it's sort of mixed results. Is it really any better than sending it to everyone? Because you're missing out on one group here. I don't know if you can see my cursor, that um, the 98, you miss those customers and they would have paid you $15 each. But you're saving this whole bunch that you didn't send a promo to and save the cost on that. Well, you can go through that $15 times the probability of buying minus zero point 0.1 times the probability didn't buy. These other two, because you didn't send the promo to them, there was no cost. And because they're not going to buy it because they didn't know about it, there's not going to be any profit. So these ones both have zeros. So that's sort of simple. And I can go through and do my calculations on this. And I put the zeros in here. Okay, just for completeness, I put all the probabilities. So these probabilities all add up to 1. Each individual something happened to. And what were the gains or losses with each? And the average is 0.134. Before, if you recall, it was 0.051. They may be small numbers, but this one's a lot bigger than the other. And then if I multiply it by my 100,000 customers that I'd send this to, before I would have been making $5,100. Now, for 100,000 customers, if I was looking at, I'd make 13,420. So I do get a better result. You could have looked at this just as classification model. What's the sensitivity? 90%. That you predicted 902 of the ones that were going to buy it. So this is of the percentage of true positives. Okay. So you're getting most of the profit that you could possibly get, 90% of that possible profit. But at the same time, on the specificity, you're avoiding those costs. Most of the people that wouldn't buy it, you've identified, and you didn't send them anything, so you saved yourself some money. You didn't waste. And so I could have looked at those two performance measures and say, hey, this is a good model because it's capturing most of those that are going to buy it, and it's capturing most of those that are not going to buy it, identifying each of them correctly. The accuracy rate is very high. But the expected value puts it in concrete terms. Why is expected value not always used when you see some broad discussions of models? Because you have to have outcomes. You have to know about what's the consequences. So from a business perspective, this puts the consequences in concrete terms. Sort of like standard error put accuracy in concrete terms. Whereas R-squared was abstract, same way with sensitivity or accuracy measures. They're more abstract. They aren't putting that risk and the consequence together is one thing. Now, this one really had consequences only for 2 out of those 4, because I had a bunch of zeros in there. What about ones that have more than that? So let me take another one. And this is the credit card example we used before, same numbers. Okay. So suppose I've got a method, and we want to know, is this a good one or not? Because we ended up rejecting some valid transactions that we ended up rejecting 990, and they were valid transactions. This 990 rejected valid. that was a problem because those were good customers. And we're a little bit worried about that false detection rate that we had of, and that these ones that we missed that were fraudulent, well, there's a trade-off. To catch more fraud, I'd probably have to um, decline, reject more innocent, more valid transactions. So we had all of these rates that we were comparing, and it seemed complicated. So let's put some assumptions on this. Let's suppose each valid transaction is going to generate some profits and some fees. Every time there's a credit card transaction, the merchant, the seller, often will pay 2 to 3% in fees to get that credit, sometimes more, but it's a lot. And so if you're looking at spending $500, then out of that $500, there may be $12 to $15 in fees being charged. So it's a fair bit of money. At the same time, every time you charge things, uh, a lot of people carry a balance, and they wouldn't carry a balance and pay interest if they didn't use their credit card at all. So they're making money off of you out of being charged interest and out of the merchant. And uh, so they make a fair bit of profit on average out of these credit card transactions. And but if it's a fraudulent one, they lose money. Let's suppose they lose $500 if it's fraudulent. Okay, I, these numbers would probably come from their accounting records. They've got historical data on losses and profits and could get these. If I have a fraudulent transaction and I reject it, nothing happens to me. I don't make money. I don't lose money. Okay, so I could view that as zero profit loss sort of situation. The But a valid transaction that gets rejected, what do you do with those? So that's my hotel bill that they declined when I was in Bermuda. Uh, I got very upset, angry on that one. That what's that worth? Would it stop me using that credit card? Would I switch? Some people would. Many people may not. But on average, what's going to happen? Because if they switch, you lose those future profits from that customer, which could be substantial. So let's put a figure on it. Let's just put it as twice my profit as a figure, okay? Say $30. What would be the expected profit? I can go through the analysis, same sort of way I've done before. I've got $15 times the probability that it was a valid transaction that was accepted. Yep. $500 if it's a fraudulent transaction that was accepted. I approved it, and that happened in 200 out of the 100,000 cases. These were the 990 valid ones that I rejected. So it's a probability 0.099, almost 1%. And I'm going to charge them $30 for each of those. And then here are the fraudulent ones, the 800 fraudulent ones that I correctly rejected. And so the probability 0.008, but there's no profit, no loss. In total, I make $13 in profit per transaction on average. That's pretty good business because I'm doing millions and millions of these a day. Um, is it any good using that model? Well, what if you had no model at all? That was sort of like the marketing promotion when you sent it to everybody and you didn't target it. So if I didn't use any model, then what would I be doing? I'd probably be approving every transaction because only a small percentage are fraudulent. I was saying it was only 1%. So I'm not going to hurt the 99% that are good to catch that 1% that are bad. I'm going to focus on the big guys. I'm going to prove everything. And I'm going to make, of those good ones, all the good ones I approve, I'm going to make $15. Huh, that's good. It's extra money. But of that 1% of bad ones, I'm going to lose 500. And the expected profit is only $9.85. Still profitable, even without a model. But I'm going to make, on average, almost $4 or $3.50 more by using my model. So the model is good at approving these. But so um, the numbers all work out right. But should I believe them? Should I question these? This is historical data. And if I presume in the future that behavior is going to look like I've seen in the past, but I haven't used this model before. Okay. I have got historical data on profit I make from a good transaction, how often good ones come through, losses I incur on fraudulent ones, and how often they occur. So I have to now take into account of a new case because I've not used the model before. So I've not rejected good customers before. And from the model, I can work out how often that's going to happen. But I don't know about the consequences. Should I believe the $30? I don't know. I really don't because I haven't done it previously. And very often in our models, we will encounter cases where some of the numbers we don't know. It does not mean you stop using the model, that you walk away from it just because you're missing some data. That you can try working around that. So, because I don't want this all to fall apart. I'm presenting my analysis. Here's my model. Please use it. And they said, well, where'd you get the $30 from? I don't believe that. That if it was higher, probably you'd get different results. Take it away. I don't like it. You don't want to get in that situation. Be prepared to be challenged. So, um, what we might want to do is sensitivity analysis or what if analysis. You did some of this in Quant 1. What if analysis, sensitivity analysis should be something you do on a regular basis when you've got some hesitancy about some of the numbers that are there, and that you want to be ready if you're challenged on your work. That the what I could do is go and try a variety of different values. And that's the easiest way to do sensitivity analysis generally. Say, well, what if it was $50? What's if it's $100? What's if it's $3? Let's try all kinds of different things and see how the results change. And often that's what we end up having to do just by experimentation, and we do it trial and error. If there's only one thing you don't know, and that's all we have in this case is one number we don't know. If there's two or three, I might do it through experimentation. But if there's only one, we can often do like the equivalent of what you did when you did break-even analysis. In break-even, you did a what if, that, if these were the costs and the revenues and so on, how many units do I have to produce to make a profit? Or if you were making a certain number of units, how high could the unit cost be and still make a profit? How low could the price be and still make a profit? That's examples of sensitivity analysis. So it involves a trade-off. It's a break even. You're going to compare one thing to the other and see where do they balance. And okay, if you're on one side, this is better. On the other side, that is better. So with break even, you're really equating revenues and costs. And when are revenues bigger than the costs, or when are costs bigger than revenue? Same way here. So we have two choices. Use the model, don't use the model. When should we use the model? When we don't know what the value is of goodwill. It's not $30. So if I don't do anything, I know the answer. That was $9.85. That was when I approve every transaction. So that one's fixed. If I use the model, I've got the figure on profit. That's fine. the one on fraud, that one's fine. And then there's this one where I've got a goodwill value. Before it was $30. Now I've just got a word in there, and it's probability. And I like putting the words in, so I know what I've got. I don't like X's. So I put it in there, did my calculations, simplified it. Okay, let me rearrange to solve for goodwill. So I could take that to the left or flip things back and forth and divide. Anyway, I get it down to $389. So if goodwill costs me to keep that customer happy is going to cost me less than $389 each time it happens with a customer, uh, then I should use the model. And if it's more than this, then I shouldn't use the model. That that if you're looking at this type of thing, uh, if you were booked on a flight with WestJet, flight got canceled because of COVID, you're losing your seat, your trip, and WestJet has to make an offer to you, and they say, "Oh, we'll give you a credit." You're getting an upset customer. They should be offering you a bit more than just a credit towards a future flight. That this is the type of thing where, well, what would I have to give them to not, from a profit perspective, that my expected profit would uh, be positive by using this model, using this approach. This is the type of thing that you do. You do a break even, a sensitivity analysis. And the airlines have done that. They may not treat every customer the same. They may have a model that uh, compensates you for goodwill, different amounts for different customers, because they know different things about those different customers. But it's beyond the scope of what we're doing here. I'm just trying to point out this expected value approach that focuses on the taking account of outcomes and the consequences. So I'm not just looking at the chance of things happening, but taking consequences into account. Even if you don't know all of the consequences from a dollar perspective, you can do what if type analyses to it and make it applicable. So this is good. This is a fairly robust sort of approach. I think it's important. It's not traditionally covered in any of the books I've seen on data mining and data analytics about one-time decisions. And it's understood why. You know, one-time decisions, you can't talk about an average because it only happens once. But um, to do the data analysis, we need a lot of past cases to look at. 100,000 customers from back before, or 1,000 customers. I need a sample of data, and I'm going to be applying it to the future where I think there's going to be more cases. So I'm not talking about a unique situation where it's only going to happen to me once. It's going to repeat itself. And so it makes sense to look at averages. But I think it's still important that if you want to understand risk and how people behave with risk, you need to look at infrequent decisions. And this, some of you have raised in your comments about, are you going to take the vaccine? So there are two perspectives you can look at that. And some of you have been saying, oh no, the more people vaccinated, the better. It's going to protect everybody. And I will be protected because more people around me are protected and that type of thing. You're looking at average. Public health people are looking at average. But then there are other people that'll say, oh no, I'm not going to take it. I don't want to do this. You're not going to have an average. When you take the vaccine, you're taking it once, well, plus a booster. But it's not an average thing with you. You take the vaccine or you don't. For the individual making the decision, it's not a repetitive decision. It's a one-time decision. For society, it's a repetitive decision. For public health, it's a repetitive decision. So in some of these, from the customer responding to an offer, it's a one-time decision. From a company making the offer, it's a repetitive decision. Remember, you've always got more than one point of view in your question. And I think in a lot of the data mining, we at times forget from the firm's perspective, we're pushing outwards and we can talk of averages, but from the recipient's perspective, it's going to happen just once. So maybe their view is going to be different. Let's look at their view. And one of the best examples of this is the coin flipping thing. So if I were to make you an offer, I'm going to take a coin, I'm going to flip it 100 times. Each time it comes up heads, I'm going to give you a toonie. I'm going to give you $2. But if it comes up tails, you're going to give me $1. Oh, it's a good deal. Would you take the bet? Almost everybody would. And there have been lots of experiments generally on students where this type of scenario has been put, and they've been asked would they accept the offer or not. And the vast majority of people say, well, yeah, the expected profit per bet is 50 cents. So gain of $2 with a probability of 0.5, a loss of $1 with probability of 0.5, expected value of 0.5 or 50 cents per bet, 100 flips, 100 times 0.5, $50. Why wouldn't you take it? That the But if we change this and change it around, suppose I flip the coin just once. If it comes up heads, I'll pay you $200. But if it comes up tails, you pay me $100. The expected profit is exactly the same, $50. Would you take the bet? Again, you put it to a group of people, and you're going to find the vast majority are going to say, no, I can't lose $100. Okay, they're afraid to lose that. And yes, it would be nice to have $200, but I'm not going to forego 100. Uh, and just I'm uncomfortable with that. That we can show that there's a lot more variability in the outcome. That in this instance, it's all or nothing. Gain 200 or lose 100. In the previous one, we can show that the gains and losses actually are, you're probably almost always going to win money. It's just a matter of how much. Some people would actually gain more than $50 because remember there are 100 flips. The average would be 50, but it's oh, now I can't think. How much is it going to be? 0.5. Oh, my brain's not functioning well enough this morning. But it's going to end up being probably between, I think, about $30 and $70 is what you're going to gain with the previous betting situation. It's very unlikely you're going to lose anything. So it's a different context. It has the same expected value, but it has more risk associated with it. And even if you didn't have the math behind it, perception is more risk. That there's, I've only read a little bit about the psychology of risk. It's not my area at all. I'm not into psychology, but I ran across much of it by accident. But the uh, this risk reward trade off, there's a lot of psychology behind it. It's focused mathematically in finance, and when you take finance, you'll get into how they measure risk, how they measure return, and there are different thoughts in terms of making the best trade-off between the two. There may not be a single one, but there may be what they'll call an efficient frontier. But it is important how information is conveyed. And this I'm thinking more in understanding risk and people's fear of risk, that when you're finished your work, you're making a presentation, you're writing a final report, you would like the audience to believe you and act upon your recommendations. How are we going to do that? How are we going to get them to get the buy-in on it? And again, it's interesting to see how they understand things, that how they treat different probabilities different ways. If I gave you a 45% chance of getting 6,000 and a 90% chance of 3,000, so one is much riskier than the other. Returns are both very good. You're going to make money regardless. There's no losses here. So would you like a chance at getting $6,000 or to be almost guaranteed of getting 3,000? People will go for the $3,000. They would, with, uh, when they're confident they're going to be getting something. They will more often go for the sured thing than gamble on doubling it, unless they're on a game show. But even on a game show, once the monetary amount gets big enough, they're going to say, no, I'm not going to gamble. If it's a small monetary amount, they'll gamble. But the bigger it gets, the less likely they are to be willing to gamble. And the same thing happens with the probabilities. If I redo this, but the probabilities I make really small, so it's more than likely you're not going to get anything. There's only a small chance you're going to get anything at all. That are you going to go for, and again, I've got one whose probability is twice as big as the other, but whose return is only half of the other. And when the probabilities are really small, we're quite prepared to gamble. That's the whole idea behind lotteries. The chance of winning is really small, but when you see that big jackpot, even though the probability of winning is 1 in a billion, you can say, the ticket's $5. I can afford $5. It's a small amount that I'm investing, and if I win, it's an enormous gain, and they'll gamble. So if the probabilities are really small, we're generally prepared to gamble. If the probabilities are larger and the returns are fairly large, then we'll tend to go for the sure thing and not gamble. So there's a bunch of these things. And you got to think about these how we think about returns and risk. And there are lots of other examples that are out there. And you can even take the same problem, same probabilities, and just rephrase it differently. If you rephrase it in terms of the negative stuff, it scares people. If you take it and phrase it in terms of the positive things, then they'll take a bigger chance than if you phrased it in terms of the negative. There were some experiments done to do with if you could do something and save lives versus and phrase it in terms of the chance you could save them, people will go and take the risk. But if you phrase it in terms of the lives lost, then they won't take the risk. It's really different. Um, so why is it important? Again, you're going to have to communicate your findings. And to ensure that your recommendations are going to be persuasive, you need to understand that psychology of risk. You need to understand what risk the business is willing to take, and try to explain it in their terms. So there isn't a straight answer here, not a right or wrong. It's understand your audience, and you've got to tailor your message to the audience. And if you mess it up in your communication, all the work you've done may end up getting lost. They're going to be negative in terms of interpreting your results. So it's not spin, but if you're making a recommendation, you're going to have to sell it. And that selling things is something that you do all the time. You're going to sell yourself in a job interview. On your resume, you're selling yourself. When you're making recommendations, you're selling your recommendations. I don't mean to be dishonest. I want you to be transparent, truthful in that, but don't make things alarmed in some fashion. Um, that that be careful how you're phrasing it. So, um, recap on evaluation, because we talked of some slightly different things last time. Evaluation is something you should be doing on a continuous basis. You always should be checking, am I on time, on budget? Are my objectives still the same? It's like doing an evaluation in, prepping for a test or an assignment. Uh, watch that deadline. uh, with projects, deadlines are important. Um, they may be flexible, and there are many instances where we can revise deadlines. Sometimes there's a penalty associated with that. Um, more often than not, there isn't a penalty. Firms, um, they sometimes with construction projects, you'll get folks getting upset that, they're a month late. They should be penalized for that. And it's generally you can't penalize them for being a month late unless you're also going to reward them for being a month early. And at least in public sector projects, they don't want to give out rewards because that means they've got to come up with extra money. The budget is often trumps time. So to keep on budget, we may have to relax on time and make some trade-offs. But you've got to be monitoring them. No surprises. And you've got to watch out in terms of your objectives. Are they still the same? Has it changed? That the I'm concerned with some projects. There's one that I can't get into, but was put on hold some time ago. The planning was done some time ago with specific objectives. It involved getting some government funding that never came through, but the project was defined in part by requirements to get funding. So that's not going to happen, but the project is still moving ahead. Things have changed a lot over that time, and the objectives may well have been different if we hadn't had to tailor it to funding. And COVID has created a massive amount of uncertainty. So we don't know if the project would have the same outcomes in a post-COVID world than we thought it would have in a pre-COVID world. So it's one where myself, I would hit the pause button on it and go back and look at it because I think the objectives, if you looked at them seriously and the anticipated outcomes, I think have changed. And uh, there's a cost involved with pausing, but still, it may be before it's too late. Let's move it to the left, move it to the right, whatever, so that we get better outcomes in the end. But and you should be evaluating your process, particularly in a data mining context, that you're going to do similar projects in the future. Maybe not exactly the same, but if I was in the marketing business, I'm always looking at how to tweak things to get customers engaged. And so I'll do a new project, a new experiment, collect new data, whatever, but they're similar in many sorts of ways. Are there things that I learned by doing this project that I would go and do differently in the future in terms of redoing things? That I've done surveys of you. I did survey of last year's class, I did the fall class. I go back and look at what we did there. Is there something I should do to, at the moment I'm worried that my response rates are starting to slide. So maybe I need to package this, present it differently so that I can increase the response rate. Some of the questions probably aren't telling me that much. Maybe I should remove them, put other ones in. At the same time, there's some of them I'd like to track students over time and see changes over time. So if I change the question, it's disruptive. I can't compare this year and last year because the question has changed. And phrasing the question can have a profound impact on responses. And uh, if you're comparing consumer attitudes on something, it's hard to look at how their attitudes change over time if you phrase the question even slightly differently. And this is happening in the U.S. with um, uh, their. You've probably heard about them spending almost $2 trillion on COVID relief, on tax breaks, grants to people, giving them money to get them through the pandemic. And different surveys are getting very different responses from people about their attitudes. Are they spending too much, spending too little, spending it in the right places? And all they need to do is either phrase the question slightly differently or in a different order. So some that talk about, well, do you think it's appropriate to spend $2 trillion? If they put that question at the beginning, people will say, no, that's too much money. They put it at the end, they're more open to it because in the other set of questions have to do with the potential benefits of spending the money. So if the benefits are given first, they'll say, oh, maybe it's not such a bad idea. If the benefits are given last, then they're at the beginning, they say, don't spend the money. So surveys, there's complications there. These are projects. So what did you learn in doing it and being consistent in how you do projects? So those are important things to learn, and you shouldn't leave it all to the end. You should be continuously evaluating this. With respect to data mining projects, data analytics projects, we need to evaluate models. That's an important thing in seeing if performance matches our objectives, matches our measures of success that we defined at the beginning. What is success in our project? And recognizing our models are not perfect, that they're going to make mistakes, there's going to be error, and that looking at either the size of the error in value estimation or how often you make big mistakes, that may be the way you're going to phrase it, that I don't care about the average error, but I don't want the chance of making a big mistake to be more than 2% or something. In classification, we're looking at all the different types of mistakes and how often we're making them. It's it's so complicated with classification because there's so many different types of mistakes. In value estimation, it's the same type of mistake, but it's just how big it is. It's easier to wrap your head around. And that all of these different measures are overwhelming, can be really confusing. It's, oh, I can do better at this, but I do worse at that. How do I make the trade off? Expected value is attractive in balancing these off, but you have to get your head open to the idea of averaging, because in averaging, you're still accepting you're making mistakes. You may be accepting that you're going to have some very serious mistakes you're making, but it's for the greater good or whatever, that some people will die, but more people will live, whatever. But that average, the firm has to provide information about consequences of those different things to be able to evaluate it properly. It is not maybe appropriate for single events or when you are looking at it from the perspective of different decision makers. And that you have to recognize that in some decisions, we are not rational. We're inconsistent in our decisions. We take big risks in some cases, and we're scared to take risks in others. That are you looking at problems from the perspective of society or the individual? So there's complexity here that math doesn't math is not so straightforward. That um, they you need to understand your audience on this, or multiple audiences. It may be you're presenting it to government officials who then have to present it in the legislature, and there's going to be special interest groups that are going to be for or against these types of things. Understanding maybe the multiple audiences. Again, how do you phrase things? Um, those communication skills are so, so important in it. And if you use the language inappropriately or incorrectly, you could create more problems. So, again, be transparent, be clear, be honest, but um, we've seen many individuals, many politicians of late, mishandle their communications, and they get themselves into trouble with it. So the last thing, and what I'm going to try to do in one class on Wednesday, is bringing closure to this. How do we bring closure to the project? We're bringing closure to the course. What are the deliverables we should be giving to the client? And that actually takes the form of several sorts of reports that we may be giving to the client, and we should be preparing a report for ourselves, that lessons learned, so that we can do things better in the future. And I do want to look at how to present your analyses effectively. And I'm going to focus primarily on charts. I've seen so much bad advice out there on how to do charts. So many awful charts and misleading charts out there. And uh, there are some good books written on that. Uh, one of the other instructors, so one of the other instructors was presented with a book by a student that uh, the firm that the student worked for, every employee is given a copy of this book. It's a fairly old one by a fellow named Edward Tufte, who wrote a book about the visual display of information. He's written some other books. Some of them are confusing, I find, but it is argued quite strongly about the importance of doing it well, telling a story through your pictures. And we'll talk about that next class, probably our last class, and we'll bring closure there. And I think that's it. I thought I was going to ask, one other thing. Um, yes, about videos. Chrome is working. Uh, I've turned my camera off for Loom, but it's on for Top Hat. It seems Windows does not like its camera outputting to multiple devices, so I suspect that I have got my recording problem fixed. But I'm interested to know, of the recordings for the course, if Chrome has done this properly, I can upload this to YouTube. And I was reading through some of the feedback about the course and about videos, and there was mention about video quality, and uh, it seemed to be contradictory, but I'm not quite sure. Because some people were talking about Zoom as well, and I guess some of the other instructors may have used Zoom for doing recording. But I would be interested if you can email me or say things in the chat or whatever. Feedback on uh, for videos in the course, uh, if I can use the product I was using before called Loom, and the one it looks like it's worked today, I can upload it to YouTube and I can make the video outside of Top Hat. If I use Top Hat's recording, which I've been doing for the last 2 to 3 weeks, you can only access it through Top Hat. On YouTube, you can always access it. Uh, but the YouTube, from what I understand, there are issues with students in China getting access, but I think they can get access to the videos through Top Hat. There's lots of trade-offs. But since I've only got you for today and Wednesday, I would appreciate any feedback you've got on videos and video quality or video accessibility between the two media that we're using. Anyway, got to go. And we hope to say goodbye to you on Wednesday. Bye now.